This one is the standard PDF function, which means for N01, which is standard normal distribution with a mean of 0 and the variance of 1. Which the PDF of the function is given by the right one. If the variance is smaller, which means the band of distribution is smaller, so this should be the PDF for mean of 0 and variance is 0.1. And for this one, for the blue one, which is just a translation of the red one to the left-hand side, which means that the mean is -1. However, the variance should be exactly the same, and this one because the shape of them are the same. And for this translation, which means that the mean equals to 1. So using this method, we can easily draw the PDF functions. And for this one, if the variance is very large, which means that the data might be quite distributed, so the distribution, so the density function will be something like this. So using this method, we can easily draw the PDF functions. And these are the cumulative distribution function. You can draw them directly by the command. And there are other distribution functions, Poisson distribution functions, and other functions, relay distribution functions, and we will not explain them too much now. So in this way, we can easily draw the probability density functions and also the cumulative density functions using the similar commands. So let's go to the problem of solving probability problems. And in theory, we know that the probability where theta is smaller or equals to x is described by f of x, which is cumulative distribution function. This is a theoretical representation. So in this way, we can find the probability for this event. We can easily find the probability. And for the event like this, then the probability can be obtained by the difference of two cumulative distribution functions. And for the probability like this, we can easily find the problem for the result, like 1 minus the distribution function. So this is the theory. How can we use this theory to solve certain problems? And here is the example. Suppose there is a relay distribution with a parameter b equals to 2. Then we need to find the probability of x fall in this interval. We want to find the probability. Suppose this is the distribution function of relay distribution, the PDF function. If we want to find the probability where x fall in the interval from 0.2 to 2, what we are trying to get is the area. So this is the theoretical, so this is the interpretation of the original problem. Or, in other words, we can find the probability where x fall in this area, we denote it by f0.2. This is the distribution. And this one is the density. And for this point, we denote it by this one, which means that the area of this part. So the probability of a certain point x fall in this interval should be f2 minus f0.2. So this is obtained by definition. So now our problem is how can we find the f? F in this example is we must remember the keyword. Really distribution RAYL. So to find this one, in Matlab we can use a keyword like this and CDF for the distribution capital F. We have B here and 0.2. So the value of F 0.2, this one, can be obtained by using a Matlab command RAYL, this keyword, and this one is suffix. So with the command like this, we can find easily the probability. And similarly, we can find capital F2, and we get equals. So a certain variable for in this interval can easily be obtained by a Matlab function like this. In this case, b equals to 1, and we can find p1 I use the argument in the wrong order. So for P1 we can easily obtain using this command, and P2 we can easily obtain it using the other command. So the probability can be obtained using a command like this. And from the results, we can say that for a certain x fall in the interval 0.2 to 2, the probability is 0.8449. So in this case, we can find the probability using this command. And for another question, what is the probability when x fall into the interval from 0 to infinity? We have to find f1 first, and then f1 means that the probability fall in this area. So for our original problem, we are expecting the area in the other part. So we have to use a command like this to find the probability. So the result can also be obtained easily. And if the joint PDF is defined like this, so how can we find the probability where theta is smaller than 1/2 and eta is also smaller than 1/2? It is also an integration problem. So this one can be obtained by using commands like this, where we have to find the integration.
ولا